Graphing quadratic functions is a process that involves quite a few moving or working parts. So here are all the parts that you need to know in order to actually graph. And so first of all, you have to determine which way the graph opens. You need the vertex, axis of symmetry, the y-intercept, the x-intercepts, and usually a couple additional points just to make sure that you are on the right track. Now, when we're talking about additional points, we are talking about points other than your vertex or your x-y intercepts. So when we are graphing the quadratics, we are plotting all of those specific information. So here I have a list of them right here of the things that we are doing. So we are going to make sure that we plot each of these concepts into your graph. And so what happens is you're usually given a formula or a function, and in this case we're in standard form. And so you have to be able to know how from standard form to find your vertex, axis of symmetry, y-intercept, x-intercept, and others. Okay? So first things first is a couple things that we need to remember. Your vertex is made up of the points h, k. And when we don't have h and k in our formula, we have to use the vertex formula. So that says negative b over 2a, my function evaluated at negative b over 2a. And so this would be how we would actually find the vertex from standard form. So here we're going to have a, b, and c. And so you can see we would plug them in to get our values. Okay? So let's go ahead and take a look at that. So the first thing we're going to look at is that vertex. So we need to find the h, which is the same as your x value. The k would be the same as your y value. So here, if we're looking at x, we would have negative b over 2a. And so in this case, what we would do is we would have negative b, so my b is 2, so this is negative 2 over 2 times 1. So negative 2 over 2 is going to be negative 1. Once we find that out, we have to now evaluate f at negative 1. So this is going to be negative 1 squared plus 2 times a negative 1 minus 3. So negative 1 squared is 1. 2 times negative 1 is negative 1. So we have 1, or minus 2 minus 3. And so this is going to give you a negative 4 as a result. So your vertex point here is going to be the point negative 1, negative 4. So we are on our way. Now, when you're graphing, if you're graphing by hand, you could either find all of the pieces first and then graph, or you could graph as you go. When graphing by hand, I personally like to graph as I go just because it helps me keep everything straight. And so here we're going to go ahead and graph the vertex point, and I'm going to graph it using red. So I'm at the point negative 1, and then 1, 2, 3, 4, negative 4. So my vertex is going to be down here. Okay. So now the second thing that I need to identify is I'm going to identify my y-intercept. Now the y-intercept essentially means that you're going to do f of 0. So this is going to be 0 squared plus 2 times 0 minus 3. So my y-intercept is at the point 0, negative 3. Okay. Now the shortcut method to your y-intercept is to remember that the y-intercept essentially is your constant. Now with that, I'm going to go ahead and do my y-intercept here in blue. So we're at 0, negative 3, so 1, 2, 3, so that would be this point here. Now there's one thing that we know about quadratics, and that is that from your vertex, you are mirrored on either side. So I know that I have a point here at 0, negative 3. I also should have a matching point over there at negative 2, negative 3. And that is something that we can check as we go through and move through. The third thing that I'm going to look at is my x-intercepts. So to find your x-intercept says your y is 0, and then we have x squared plus a 2x minus 3. And so here what happens is we need to solve this, which equals 0. So this is going to break down into x and x. I have factors of 3 that have to add to give me a positive 2. So my factors of 3 are going to be 1 and 3. I want a positive 2 here. So I have positive 3 minus 1. And so here when you solve, it means I now do x plus 3 equals 0, x minus 1 equals 0. So my factors are going to be at negative 3 and at 1. So that means my x-intercepts are going to be negative 3, 0 and 1, 0. So just like before, I'm going to go ahead and I'm going to plot these. So I'm going to use my orange. So 1, 2, 3, 0 is going to go here, and then 1, 0 is over here. And so you can start to kind of see the U shape appearing as we go. Now, the fourth thing that I'm going to look at is that axis of symmetry. So the axis of symmetry says that we're going to have x equals negative 1. And so here, what that means is we have a vertical line that is going to drop straight through. And I'm going to turn this sideways. But this vertical line is going to line up right straight through here, and it's going to cut through that vertex and keep going down. So this is your axis of symmetry, and what that line means is that if I were to take this graph and fold it in half along that line, everything that is mirrored on the one side mirrors onto the other side. Okay, and so they are exact mirrors. So when you fold them up, all of your points should line up. Okay. Now the last thing we have is the extra points. So again, I said that we should have this point right here that shows up because it's going to be mirrored where my y-intercept is, so we can check that. When we're looking at this point, we're saying that it's negative 1, negative 2, so x is negative 2. So here, f of negative 2 is going to be negative 2 squared plus 2 times a negative 2 minus 3. And what I'm hoping is that when I do that, I get negative 3 as a result. So negative 2 squared is 4, and then I have 2 times negative 2, which is negative 4, so 4 minus 3 is going to give me that f of negative 2 is negative 3. And so I do get that point that I was expecting at the point negative 2, negative 3. Now after that, I still have to find one more point on the graph that I can use. And so I'm going to take a look at where my x-intercepts are, and I'm going to say, okay, well what happens 1, 2, 3 if I go out one more, so out here at negative 4, where am I going to fall? And what if I'm out here at 2, where am I going to fall? Okay, so here I would go ahead and say, okay, let's look at f of 2. So this is going to be 2 squared plus 2 times 2 minus 3. So f of 2 is going to be 2 squared is 4, plus 4 is 8, minus 3 is 5. So this tells me that I also have the point 2, 5. Now all you wanted was 2 points, and we have those, but you could go one further. And so if we look, and I'm going to go ahead and use my purple pen for extra points. So I have the point at negative 2, negative 3 right here. Now if I look at 2, 5, I'm going to go over 2, I'm going to go 1, 2, 3, 4, 5. So I've got my point is right here. Notice from my intercept I only went over 1, which means I automatically know if I go over 1 on the left hand side down to, over to here, I'm going to be up at the same place. 1, 2, 3, 4, 5. So it'll be up right here. And so those are my extra points that I have, which means I've graphed everything I need. The only thing that is remaining is to go ahead and connect the dots. So I'm going to go ahead and do that. So we're going to come up on the one side, we're going to go through all of the points that we have graphed, and we're going to keep on going and do the same to the other. We're going to go through all these points that we've graphed and keep on going. And that is everything that you need to do with your quadratics. So as a refresh, this bottom point down here is your vertex. Okay. This next point up, the one right here, was your y-intercept. We then had our x-intercepts, so we have this point right here, which is an x-intercept. And the same with this one here. This one is also my x-intercept point. And then I have my extra points. So this right here was an extra point. Along with these over here. These are also the extra points. So this one here, as well as a third for good measure, this one down here. Now the last piece that we have to look at was this line right here, and this was my axis of symmetry. Okay, so that is everything in my quadratic. Oops. Alright, let's look at another one here. In this case, my squared term is negative, which means my graph in this particular case should open down. Again, we have to start out with your vertex. So here I'm in standard form, so I'm going to have that my x is going to be negative b over 2a. So this is going to be negative of my negative 4 all over 2 times negative 1. So here this makes it a negative 2. I then have to do f of negative 2. So this is negative of my negative 2 squared minus 4 times my negative 2 plus 2. Again, if I solve all that down, negative 2 squared is 4. Apply the negative is negative 4. Negative 4 times negative 2 is a positive 8. So this is negative 4 plus 8 plus 2 is going to give you 6. Making my vertex the point negative 2, 6. So again, I will go ahead and graph that. 1, 2, 1, 2, 3, 4, 5, and 6 up here. I then need to do my y-intercept. So my y-intercept in this case is going to be at the point 0, 2. Now, notice your y-intercept is where your x values are 0, and so these two would drop out and leaves the positive 2 as the only thing that's left. The third thing I need to look at is that x-intercept. My x-intercept occurs when the y is 0, so this is negative x squared minus a 4x plus 2. I can pull out the negative, so this becomes negative 1 times my x squared plus a 4x minus 2. If I divide that away, I have x squared plus 4x minus 2, which I can then, nope, I can't. In this case, I would then have to use my quadratic formula. So here I have that a is 1, b is 4, and c is negative 2. So my x is going to be negative 4 plus or minus the square root of 4 squared minus 4 times 1 times negative 2. And this whole thing is going to be over 2 times 1. So here we're going to end up with negative 4 plus or minus the square root of 24 all over 2. We know 24 can break, so at this point, remember, you need to reduce here. So we've got the square root of 24 is going to break down into 4 and 6. We know 4 is a perfect square. And so here this is going to become negative 4 plus or minus 2 square roots of 6 all over 2, which is going to reduce further and become negative 2 plus or minus the square root of 6. So we could go ahead and state that that is what our intercepts are. So we're going to have the intercept at negative 2 plus the square root of 6, 0. And we're going to have negative 2 minus the square root of 6, 0. But with that, I can go ahead and look at those decimals so I have a good idea of where it is. And so this is going to be 0.449 and negative 4.449. Okay, so those are just rough estimates, but those are where my intercepts lie. So I have my two intercepts that I need to graph here. So first let's go ahead and graph my y-intercept at the point 0, 2. So 1, 2. So that's going to be here. So if I take a look at where my vertex is, I had to go 1, 2 over to get to my intercept. So here I'm going to go 1, 2. I should have a point that occurs opposite it. And now the other thing I have is I have my x-intercept points. So my first one is going to appear at 0.449, so that's, say, roughly right here. And then my second one is going to be negative 4, so 1, 2, 3, 4, and almost a half, so roughly right there. And so those are my two x-intercept points. Okay. Now, I also have to take a look at that axis of symmetry line. Now we know the axis of symmetry is going to be the x value of my vertex. So here my vertex is at negative 2. So this is going to be x equals negative 2. So I used my orange for my x-intercepts, and I'm going to kind of use this kind of pinky color for that axis of symmetry line. And so we're going to draw it. It's this vertical line that comes straight down my graph at this point here. Okay, so this right there is my axis of symmetry. Now the very last thing that I need is I need my extra points. Okay, so the fifth thing that I need is the extra points. And so here I already am guessing that I have the point right here, which is 1, 2, 3, 4, 1, 2. So I am guessing that I have the point 4, 2. And so I can go ahead and use that I have that point negative 4, 2. And then I need to find a couple more. So if I'm looking at my points here, one thing that I can ask myself is, okay, what were to happen if I graphed the point 1? So what if I said f of 1? Well, this would be negative 1 squared minus 4 times 1 plus 2. So here, 1 squared is 1, so this is negative 1. Negative 4 times 1 is negative 4. So I have -1 minus 4, which is -5, plus 2, which is -3. So here I'm going to also have the point 1, -3. So if I go ahead and take a look at those, my extra points here, I've already proven that I have my point right here, the one that I was guessing would be there, but then I also have the point 1, -3. So I'm going to go over 1, 1, 2, 3, so I have a point right down here. Now that being said, it means that I should have the exact same point on the other side, and so here that means I should have a point here at -5 and 1, 2, 3. And that is because this is a mirroring quadratic. It mirrors across. And so the only thing left to do is just simply connect your dots. And so here we're going to go ahead and do just that. We're going to draw our graph kind of going straight down through our points. Keep going down through the other side. And there we go. Okay. Alright, now the last one I wanted to look at has to do with what happens if you don't have an intercept. Okay, so first and foremost, again, we need to look at the vertex. So we'd have that your x is going to be negative of the -4 over 2 times 1, which in this case is going to give you 2. And then I have to do my f of 2, so this is going to be 2 squared minus 4 times 2 plus 5, which gives you 1, making my vertex the point 2, 1. Okay, now for this one I'm going to show you what happens if you find all of your information first and then go in to try and graph it second. Okay, so we found the vertex. The next thing we need to look at is that y-intercept. So everything drops away, everything drops away here, and the only thing that's left is my constant. So my y-intercept is the point 0, 5. I then have to find my x-intercept. Well, one thing I know when I'm looking at this is that first of all, my back term is positive, so both terms are positive. And my middle term is negative. So both of the terms are going to be negative, which multiplies to the positive. My only factors of 5 are 1 and 5. There are no combinations of -1 minus 5 that's going to give me -4. So automatically that tells me that I have to start by using the quadratic formula. So this is going to be 4 plus or minus the square root of 4 squared minus 4 times 1 times 5. And it's going to be all over 2 times 1. So in this case I have 4 plus or minus the square root of -4 all over 2. Now in this case, when we look at this, it's negative. And so here one of the things that we know is that you cannot have a negative under the radical. What this means is that you have no real solutions. Okay? Since there's no real solutions in general, what that means is that we do not have any x-intercepts. Okay? And so here, what that's going to tell you is that your graph is either going to fall completely down underneath the x-axis or it's going to fall completely above the x-axis. It's never going to cross it. Now with that, we still have to identify that axis of symmetry. Which in this case is going to be that x is 2. And then the last thing is to identify the extra points. So here, to identify my extra points, I'm going to go ahead and look at graphing what I do know. So first and foremost, I know my vertex. So my vertex here is at the point 2, 1. So 1, 2, 1. There's my vertex. I know my y-intercept is at the point 0, 5. So 1, 2, 3, 4, 5. So that's going to be right here. That also tells me that I have an extra point that's going to be up here at 5. It takes me 2 to get over here to my axis line, so it should be right over here on the opposite side. I do not have any x-intercepts, but I do have an axis line right here. That again cuts straight through your vertex and goes all the way down. Okay? And so that's what this is. So this line represents your axis of symmetry. So now I have to go on and find my points. So I can already assume that I have my point here. And so this is at the point 1, 2, 3, 4. 1, 2, 3, 4, 5. So I already know one of my points is at the point 4, 5. And that is based on your y-intercept value. So I need to have other points. So the first thing that I would do is I would go ahead and say, okay, let's take a look when x is 1, and then it should mirror when x is 3. So if I look at f of 1, then here I'm going to have 1 squared minus 4 times 1 plus 5. So when I do all of that, I end up with 2. Well, that also means if I look when f is 3, I should get the same answer. So this is 3 squared minus 4 times 3 plus 5, which gives me 2. So my other points are going to be the point 1, 2 and the point 3, 2. So here I can come in 1, 1, 2, so I've got a point here and the matching point here. Since everything has been labeled, I can go ahead and connect my graph through the points that I know. And in this case, what you can see is that my quadratic graph right here is totally above that x-axis. It doesn't cross it at any point, which supports the imaginary solutions you would have. So there you go. You've got 3 really good examples on how to graph a quadratic equation. If you have any questions, please let me know. Otherwise, I hope you enjoyed this video, and I will see you next time.